Hi, this is Joshua Serva from CSE 335, and I'm here to present about my mobile application project that I made, and it's called Smart Weather. So let's go ahead and get started. So what is Smart Weather? It's an application that lets users view their own backyard temperature and humidity information, and it displays this data in a meaningful way through averages and maxes and mins of temperature and humidity, and it also gives a local city weather 5-day forecast. So what that means is you get forecasted data from, like the meteorologists that post this information online, and the app takes that information as well. So you can kind of compare the data from your own local backyard to what is actually being forecasted in the news. So that's kind of fun. Just kind of do a comparison and see what's going on in your own place rather than something more generic like a city. So let's go and see how that works. So I have this thing called the Raspberry Pi, and what this thing does is it pretty much has a little sensor on it, and it gathers this temperature and humidity information onto the Raspberry Pi, and then the Raspberry Pi takes that information, and every 10 minutes or so it uploads that information to Firebase. And so Firebase then takes this information and makes sure that it's all organized and everything by day, and then this data is actually able to be accessed by my app. And so then I can display it on my iPhone here, and my iPhone can then take images that it takes pictures of for each of the days, and then these images get uploaded back to Firebase, which then can be downloaded again onto the phone. So nothing's really stored on the phone, which is cool. So it's all just staying in Firebase, so that all that information can stay there and just stay kind of pretty snappy and all available all the time. You just have to have an internet connection. So let's go ahead and take a look at the GUI. So this is the actual, this is the forecasted weather section of the GUI. So you have two options here. You have my backyard weather, and then you have my area's weather. And my area's weather is going to take you to this screen right here. And this screen is a 5-day future forecast that is given from some open weather map API call, which pretty much after you set a location here, you can actually, you can set your location. So you click that button, and then you click use current location, and then it uses your GPS, and then you get your city name here, which I spoofed in the simulator so that it can act like, because Queen Creek is where I live, so that's what the information is given through the GPS. And then all this information is given here, highs and humidities, and so these are all the days in the future. So tomorrow, the average is going to be, the high is going to be 75.7 degrees, and the average humidity is going to be 34 degrees. And you also get a cool little map showing you like where generally that is, so you can kind of see like what the general area and the general forecast of that. So that's for the just general city weather forecast that you can get just through GPS, which is pretty cool. You can also upload information here through or not upload, you can refresh the information. So it just does another API call to update all of these days so that you can get a more accurate forecast, because it gets updated about every 3 hours, but you can manually refresh it whenever you want. So let's go ahead and take a look at the backyard weather. So this is, if you were to click this button here. Now, I didn't talk about this on the previous screen, but you have this current temperature as of right here. And what that means is it looks at what the last thing that the Raspberry Pi uploaded, so the current date, and then it just looks at what the most recent upload was and tells you what the current temperature is in your backyard, which was kind of, I just thought of that just on the fly, and I thought that would be a really cool feature to implement, and it was pretty easy to do. So then you can get your information, and then you can refresh it whenever you want here, but it should refresh on its own because it's smart enough to interact with Firebase and see when there's an update. So that's pretty cool. But so if you click My Backyard Weather, it takes you to this table view here, and this table view is just all the dates that have been recorded. So you can scroll through and you can see every single date. And if you click on one of these dates, so we clicked on 11/29, then it takes you to this screen. And this screen lets you look at the temperature average for that day, and the max temperature, and the min temperature, and the average, and all that other stuff. So it's pretty cool to kind of view all that stuff. And for the current dates, this gets updated throughout, but the other days it stays the same because the weather doesn't get updated for past days, obviously. You also have a little title up here that shows you what the current date that you're looking at, which is in year, month, day, because it's easier to organize the data in that way. So that way you can have like the highest value down to the smallest value, so it's just easier to organize. So you also have this option to upload a photo, so you can upload via the camera or the library. And here I just clicked on library, and then I clicked this little upload button, selected one of the sample pictures, and then it gets uploaded here. So what's cool is that it actually it uploads the photo here and it puts it into the immediate view. But when you go back, that stuff actually resets, and this picture will actually be uploaded to Firebase, and so the next time that it goes onto this section, it'll see that there's an image URL uploaded, and I'll explain how the Firebase works in a minute. But it'll see that URL, and then you'll actually be able to display that picture rather than the upload photo of this day. So you can only upload once, but you really only need one photo to kind of like summarize what the day is. I could also change that later. I'll talk about improvements in a little bit, but yeah, that's kind of how I implement it for this project. So here are my class diagrams. We have this main view controller here, which, so looking back at the GUI here, you can see that that's what this is representing. So you've got this UI label here, which just displays the current temperature. Then this label that just gives you the current, like what the most recent one update was. And here your reference is for the actual database reference. So when you're downloading the weather data from Firebase, you use something called the database reference. So here we have our generic view did load, some unwind, home, and then we have this refresh, which updates these two labels here to give you the most recent weather information. And so that's how that gets called. This section here, the weather forecast view controller, is going to be this guy right here. So it'll be this view controller. And so we have a bunch of different things here. There's kind of a lot of things going on. But the basic thing, most of the strings are pretty self-explanatory. These are used just to kind of get the information correct when you're displaying the actual, where is it? So when you're displaying the city here, like Queen Creek, that's what that string represents in the zip code. I think that's something that was left over, but it was used just for the title up at the top. And then we have this manager, so that's how we do the geocoding when we get our information. And then we have this navigation bar, so that's just for the back button. And then there's the back button. And here's our map view. So that's the map that shows you where your current city is when you click update location. And then all of these labels just represent all of the different, the future forecasts. So days 1 through 5 labeled within the days after what are forecasted. Then this error message is used for displaying if we need to upload, if we need to set our location. And once that's done, then it gets hidden. Okay, so here's our refresh weather here, which just, I mean, pretty self-explanatory. Refreshes the weather, so it does another API call. That's actually what this, where is it? This little button here does. So that's what the refresh calls. Does another API call if there's a location selected. The show input dialog, that's for the asking to set the location. Then you've got the location info and location manager. Those work together to kind of get the GPS along with the process response. Those all use the GPS to get all that information from the GPS and to convert it into a city so that we can do the API call. Excuse me, the get weather is what actually does the API call. So after location info, location manager, and process response do all of the things that they need to do to get the GPS coordinates converted into a city, get weather actually calls the API call with the actual city selected and given like a 5-day forecast selection. And that's what updates then, get weather then updates all of these labels. Set hidden and set visible, those are just for the labels. So I have all these placeholders for the for these guys right here. So for all these percentages and everything, I just decided to hide them if they hadn't had a location selected yet. And then once they get location selected, it shows. So then we'll move on to the weather table view controller, which is this one here. So then we have our dates table, which is just our table, the reference, which once again I explained before, sorted days and post dictionary. So these are used to get the information and then make sure that it's all in correct order when it's being displayed, so that it goes from the most recent date to older dates, because we want the most recent information up at the top, and if we want to access older stuff, then we can scroll down. Okay, functions for the table view controller. We've just got some of the delegates, and then we've got the prepare, and then we've got some unwind. This detail view controller is kind of where it gets interesting, because that is what this represents, this guy right here. And so what do we have? We have the title label, temperature average, humidity average, temp max. So these are all just labels that get set based off of the actual information that's being passed, because the way that the information gets passed is that you, so the reference is here up in the weather table view controller. And once you select a day, it actually takes one of the key value pairs from these from this dictionary, and it gets passed into the detail view controller, and then the detail view controller creates something called the daily object, called that is of type daily data, and that's what's used to actually gather all of these different statistics about the day. So you have this daily data object here, which is just has one field, which is a string any object array, which contains all of these different calculations. So you can calculate the temperature, humidity, and the highs and the lows for everything. And then this information actually gets sent back to all these different strings. So rather than doing it inside of the detailed view controller, you're calculating all of the stuff that you want to calculate, like averages and everything in here. So that way all of that gets saved in the model and not in the actual view. Some methods for the detailed view controller, we have get data from URL and download image, and these are both used to just make sure that the URL that's being gotten from the actual Firebase to be correct, and then you can download it. Then you've got your upload image, which is just used to upload the image if you select it. The image picker controller stuff is pretty self-explanatory. Once again, these hide upload and show upload, so if they have a no photo there, then this gets shown, this right here, this upload photo this day, and if not, then it gets hidden and this image gets shown. So here's my MVC diagram. So I've got the controller, which handles information from Firebase, whether it including image downloading. It gets all this current location through a request, through the reference, and then there's a 5-day weather API call. So this is kind of repetitive, but just to show it in the MVC diagram. We've also got our model here, which we use Firebase, and then we use the daily data object. So Firebase just stores everything in a kind of dictionary from the Raspberry Pi that I have. It stores all the weather information, and then it also stores the image URLs. Then you have the daily data object, which does all the calculations. So then that gets spit back into the controller, which will then put it in the view, so that the view can display all that information. Then you have the view, which does, like I said, displays all this information, like the 5-day weather forecast or the weather information, and then all these statistics and stuff like that. And then you've got just some generic user actions from the view, which you can use to do certain functions in the controller, like in the model, like I explained before. So here's kind of what base idea of what my Firebase model looks like. I have, this is what a day looks like without a picture in it. So you've got your humidity and temperatures, which each have a timestamp attached to them. So they're all synced up with each other. So each humidity has a temperature, and every temperature has a humidity associated with it. So if there's no image, then I have the Raspberry Pi put this nothing label up there. So that way when the app is reading it, it makes sure it knows that it doesn't have to download anything because there's no URL there. But here for 2017, 11/19, there actually is an image URL so that you can actually use, and it will download it from the Firebase storage. And the Firebase storage, this is where I have everything download or uploaded. So here's all the different images that I have labeled. So it's just labeled by date just to make it easier for me to read. And then they all have their own little URL download, which then gets put into this image URL when the function is called to upload an image. So some general improvements that I wish I could have done is saving statistics that were calculated already so that they don't have to be recalculated on the phone every single time. I wish I could have made it a little bit more clean, my overall design. I wish it would have just looked a little nicer. I spent most of the time on the functionality, and that definitely left a little bit more of the design in the back end, so it wasn't as great looking. I wish there was more a detailed view of the weather statistics, so like getting graphs and to make it a little bit more meaningful than just statistics, because you can look at numbers, but a graph is kind of nice to look at. I also want to make sure I want to add support for multiple users, because right now this is only for me, but I could very easily convert this into something where people could get their own sensors and have them upload their stuff to Firebase, and it could all be organized together. I also think that I never saved the location info for when they did the actual forecast, so that never got saved. So I think that needs to be improved, and then loading icons so that the user knows what they can do. But overall, I learned time management. I learned to plan and then code, because you end up wasting a lot of time. And I learned to adapt to challenges, but to not change ideas too much, or else you never get anything done, and then your time management is totally off. But overall, it was a really great learning experience, and I learned a lot, and I'm really glad that I could actually apply some of my computer science knowledge into an app, and that's been very fun. And it was a lot more than a new programming language. This is what I thought it was going to be, and I really liked that I could learn about how design works when you're combining math with something that's more of kind of like not art necessarily, but a design and something that looks very nice, and while still using information that you get from through data or something, and just displaying it in a meaningful way. So I really liked it, and I really did enjoy this course. So I really appreciate all that was in this course, and I'm glad that I learned a lot. One last thing, if you do have any suggestions on the app or anything that you think that I could add or something, because I really do want to be a little bit more serious about this, I'm very interested to for you to let me know. So thank you for your time. I know I went a little bit over, but I really appreciate it.